Okay, so I want to do the intuition behind derivatives and integrals. Now, the first thing that we're going to do are integrals. So, before we do this, you need to know basic calculus, what a derivative is, what an integral is, and just the power rules. So let's start off by drawing a graph. And let's say, let's actually draw two graphs. We're going to have x squared, and we're going to have just x. Okay? Now, when we take an integral of this, that's going to be x squared over 2. Now we take the integral of this, that's going to be x cubed over 3. Right? You should be familiar with the power rule. Now, why exactly did we have to... So, what the power rule does is you increase the power, and then you divide it by whatever that power is. Now, why did we have to actually do that to get the area under the curve, which is what an integral gets you? Well, this shaded region, right? We know that it's going to be the y value, which is basically equal to x, because that's the function, times the x value, right? And then we're going to divide it by 2, right? Now, when we increase, because we're going to divide it by 2 because it's a triangle. Now, when we increase the power like this, in any case, it could be x squared. Like, for example, here we have the area under the curve, x squared, so that's going to be our y. Y is going to be x squared, and we're still multiplying it by another x by increasing that power. So it makes sense, right? Because we're multiplying it by x to get that full area. Now, the only really difference is that now we're dividing it by a different number. So we're multiplying both of them by x to multiply it by the base, which is getting you the full area of both. And then we're going to divide by a certain number. Now, this number slowly increases as the power increases. Okay, so why does it make sense that as the power increases, you have to divide by more? Well, this is x to the fourth, right? And this is x. So let's just compare x to the fourth, the integral of x to the fourth, to the integral of x. So the integral of x to the fourth is going to be x to the fifth over 5. Now that makes sense, because you're going to multiply it by x. So let's say you wanted to do just from all the way from here, right? So all the way down from that 5, so where x to the fourth was equal to 5, then you did x to the fifth, so you multiplied it by an x value, whatever the x was, right? You multiplied it by x. And then you had to divide it by a higher number, 5, because it's only a small sliver of that total area you're getting when you multiply it by x. So this is a tiny sliver, whereas the integral of x is x squared over 2, which is a much smaller number. 2 is a much smaller number. And that's because x squared, let's say you were trying to get this full area from here, and you were multiplying it by this huge x, then you would be getting this full square, and you just want to divide it by 2, right? Because you'd want to get this full area. So I hope integrals make visual sense to you now. Next we'll do derivatives.